Okay, welcome back to the second video on transformations. Just a recap, a transformation is an operation, right? It's an action that maps an original figure called the preimage onto a new figure called the image. And a transformation can change size, position, or orientation of a figure. Our transformation review, again, is a mapping or moving of a figure. Okay, that's what that mapping piece up here refers to. Mapping is just a moving of a figure. So here is our preimage, and we're mapping it to a new place called the image. There are a variety of transformations, and we've already talked about one of them. Reflections. Reflections is just the flipping of a figure. So we've got that one squared away. The next transformation that we're going to tackle are translations, with a focus on the SL in translations. Now be careful not to confuse the word transformation with translation. Again, just a reminder for all videos to keep in mind, pause the video if you need to, go back if there's something that you missed, please pause when asked and do the work, watch the video as many times as you like, or portions of the video as many times as you need, and always, always, always ask follow-up questions in class. All right, let's get started. What is a translation? Now, in your notes, you're ready to follow along with me. To vertically and or horizontally slide a figure, right? And that's why I said to pay attention to that SL in translation. That SL is where I remember sliding. And symbolic form, we want to get this into our notes, so you might want to press pause and copy this in. Okay, so we have a coordinate, right? We're going to have a bunch of vertices of a figure, and they all are located at some sort of location, x comma y. And so here's that mapping, and what are we going to do? We're going to do something to the x coordinate, we're going to do something to the y coordinate. We're going to either add or subtract a value, a constant, to both the x and the y value to obtain new values. As we do this, this will make more sense. X represents, of course, this piece right here is going to represent our horizontal change, and that makes sense because x is always left or right. Y is up and down, so of course that's going to represent our vertical change. Let's try this in action, and I think after reflections, most of this is going to be pretty straightforward. So as you might guess, I'm going to ask you to press pause, and I want you to draw the rectangle with vertices Q, R, S, T, or as we will refer to it, rectangle QRST. Draw that rectangle onto the graph, and then come back to me when you're ready. Press pause now. Now hopefully you have the same rectangle that I do. Now what we want to do is focus on this set of instructions. So as we had that generic piece up above in your notes, we said that this was referring to each point here. So this point right here, this point right here, this point right here, and this point right here. We're going to take each of these sets of coordinates. So let's take Q for example. We're going to take the coordinates of Q, -6, -1, and we're going to apply the following translation to that. We're going to add 5 to the -6, and we're going to add 7 to the -1, and that's going to give us the new location of Q prime. Now what's going to get in our way most of the time here is the adding of integers. So you just got to be careful. When I take +5 and I add that to -6, I'm going to arrive at -1. And when I take +7 and I add that to -1, I'm going to arrive at +6. And so Q was originally right here at -6, -1, is going to move to the right 5 and up 7. So let's follow this. I start at Q here, and I go right 1, 2, 3, 4, 5, and up 7, 1, 2, 3, 4, 5, 6, 7. And interestingly enough, where are we? We are at -1, 6. So you can either algebraically apply the addition of 5 to the x values and the addition of 7 to the y values, fill this in, and then plot those points, or you can hop along to the right 5, up 7 for each of these, and then turn around and count those points and fill these coordinates in. You really need to be able to look at it both ways. So why don't you go ahead, press pause, and try to move the other 3 spots, or 3 points rather. As you'll see, I prefer to look at it algebraically first, and then I'm going to plot those points. And of course, if I did this right, if I added 5 to each of the x coordinates, and I added 7 to each of the y coordinates, if I did all of that correctly and I plot these points correctly, I should get a new rectangle that is 5 units to the right, 5 units to the right, and 7 units up from my original rectangle. So let's see how we made out. How did you make out? Have you pressed pause and tried this yet? After I plotted my points and connected everything, it looks like I have a rectangle. Now I just want to go ahead and label all of my points with the proper notation. So what was once Q is now Q prime, which was once R, is now R prime, S prime, and T prime. So don't forget, your final drawing should have labeled points with prime notation and the coordinates filled in. Let's try again. To keep things moving smoothly, press pause and draw your rhombus JKLM with vertices at J, K, L, and M. Press pause now and work that out first. And here we have our rhombus, our original, right, pre-image. And now what are we going to do? We're going to take each of these coordinates, each of these x, y coordinates, and we're going to translate, right? We're going to slide this figure two units to the right, 2 units to the right, and down 2 units. And so we're going to apply that arithmetic to each vertice on the rhombus. So algebraically, let's go ahead and try to work that out first. If we take J and we add 2 points to -4, we're going to land at -2. And if we take 7 and we subtract 2 from 7, we're going to get 5. Now if we go to that location, -2, 5, we're going to land right here. And that's going to be our J prime. And now go ahead and try to do that to all of these. Algebraically, try to apply the translation. Take a look at my values here. Is that what you got after you added 2 to each of the x values and subtracted 2 from each of the y values? For instance, -5, 3, when you add 2 to -5, for m prime, you should get -3. And when you subtract 2 from +3, you should get a +1. Now I've taken the liberty of plotting all my points and connecting them. And I do have a new and improved rhombus, right? My new image. Right? I have my pre-image here, my images here. And now all I have to do is just label my points. And so K is now K prime, L is L prime, M is M prime. And each of these points is essentially the same figure hopped over 2 units to the right and 2 units down. Onward and upward. Okay, here we have a trapezoid ABCD with said vertices. And I'm just going to give you a little heads up here. What's going on? Looks like we are taking each vertex and we're going to apply the translation of x plus 4, which is which way? Moving to the right 4 units. And then we're going to subtract 1 from the y's, which means we're moving down 1 unit for all 4 points. So go ahead, press pause, draw in your original trapezoid, apply this translation of 4 units to the right and 1 units down to all of these algebraically, plot both pictures over here, then come back when you're ready. So don't press pause until you have a full and complete answer. Don't cheat. Do this one on your own, then check. There's a big difference. Okay, so how'd you do? Here are the coordinates that I came up with for A prime, B prime, C prime, and D prime. And when I take my original figure here, this red guy over here, take my red one, that's my pre-image, and I move it over 4 units. 1, 2, 3, 4, and down 1, boom, I land right on that purple one, or that pinkish one. So I think everything went well. What's the only thing I'm missing for a nice, clean final answer? Are you thinking you need your vertices labeled? You would be correct. So go ahead and make sure that yours are labeled, and I'm going to press pause and label mine. All right, looks like I got a nice full and complete answer. Hopefully you do too. And now let's continue on the journey. For this example, you're noticing immediately that things are a little bit different. We already have our figures in position. And what do we want to do? This time we want to write a rule, okay? What we want to end up with is that x, y, comma, and then x plus or minus some number, comma, y plus or minus some value, number. And those numbers have to describe what happened in the picture. Now we see the figure MNOP. That's our pre-image, and I know that because the image M prime, N prime, O prime, P prime has the prime notation. So it looks like this figure went left and up, or up and left. It doesn't matter which one you see first, as long as you get the horizontal values here and the vertical values here. So let's trace out and see what happened. I'm just going to grab maybe P for the heck of it. So I'm looking at P over here, and how did P go to P prime? Well, it looks like there was a vertical change of 2, and it went upwards. So up 2 values, or plus 2 on the Y value side of things. And as far as the horizontal change, it looks like it made a leap of faith 4 units to the left. So it went left 4 units. And that's negative 4 for x. Now we just got to write the rule that contains all of that. So we come down here and we say, all right, each value for each coordinate, right, x, y is the generic way of talking about all of the coordinates, have moved. It slid somewhere. It was a translation. And where did they slide? X slid 4 units to the left, all of them, and the y values all went up by 2. So up is positive. Negative is to the left. We know it went left for the x value, and the y values went up. And that's it for writing the rule. That's a lot easier than all the other work of plotting and counting. All right, let's move on. Now this last one is like the grand poobah of problems. Why? Because we have 2 transformations that we are applying. First we are going to reflect, and then we are going to translate. So the very first charge, right, asks us to go back and reflect across the line y equals x. So here's our y equals x line. I've taken the time already. I have parallelogram QRST. I've drawn that in, and the first thing we want to do is reflect this across the line. So go ahead, draw in your parallelogram, and then reflect. Press pause and do that now. Now just a couple of things. One thing I want you to immediately change right here is the QRST was originally called Q prime, R prime, S prime, T prime. I'm going to call those double primes. Since I'm moving twice, I wanted to have a sort of interim location of coordinates to keep track of what's going on. So if you remember, when you reflect across a y equals x line, what happens is our original coordinates of Q just flip-flop. So I counted 1.5 boxes straight towards that along the diagonal here, and 1.5 boxes lands me right here, which is where? Negative 1, 2. So what happened to Q? It went from 2, negative 1 to negative 1, 2. What happened to R? It went from 7, 1 to 1, 7, 6, negative 2, negative 2, 6, and T goes from 1, negative 4 to negative 4, 1. That was the reflection part. So that was the previous assignment, which is no big deal. Now what? Now we apply the translation to these set of points. So now we're going to take these blue coordinates, that's why I wanted to write the interim, and we're going to take all of the x's and move which way? Negative 3 is to the left. So we're going to move left 3, right? Left 3 units, and negative 7 is down 7 units. And we're going to apply that algebraically to all of these coordinates, or take each coordinate here and just hop 3 left and down 7. It might be, in the grand scheme of things, best for us if we moved each point left 3 and down 7, applied the algebraic to the coordinates, adding 3 to the x, subtracting 3 from the x and subtracting 7 from the y's, algebraically arrive at coordinates, graphically arrive at coordinates, and then make sure that our graph matches up with our math. Go ahead and press pause and let's just do one. Let's move q prime to q double prime. Now what happened? When I subtract 3 from -1, I get -4. Okay, I subtracted 3 from the x coordinate of -1. -3 and -1 yields me a -4. Then I subtracted 7 from the y coordinate and I get -5, right? -7 plus 2 is -5. When I look at that, I already hopped 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I did that manually, by using the graph. But when I count from the origin, -4, 5 is 1, 2, 3, 4, 1, 2, 3, 4, 5. So looks like my algebra works and my hopping method works. So whatever works for you, hop and write the algebra, or do the algebra and then plot your points. Either way. Finish up the other 3 points, press pause now, and see how that works out for you. Remember, we're starting from the blue coordinates. We originally started with our pre-image, went to this image, now this becomes the pre-image, and we're going to the new image. Press pause. And what do we have? Besides the fact of a very busy picture, we have our QRST final image. And just a worthy note, I originally had plotted this T double prime right here, and I said, wait a minute, that didn't look right, and actually I had to recount my ways. So it's okay if you have to erase and go back, but our final answer has all 3 pieces of, all 3 parallelograms and our final algebraic coordinates here. All right, that about wraps it up. Now, what you need to do is go back and fill in the rest of 1 through 10. We've completed a handful of problems. Now I want you to fill in the rest of the examples. So everything should be done for 1 through 10, and then check in before proceeding. All right? Good luck.